Another simple one, like 23, on still the same page, 535, we are given f prime of x equals x to 2/3 plus, minus x, sorry. And they're telling us that f of 1 equals -6. So this is x to 2/3 minus x. And they want us to determine that specific. It says, find the particular solution of each differential equation. This is a differential equation that is a simple one. I'm just given f prime directly. So this is like finding the antiderivative or the indefinite integral, same thing. Okay? So finding f of x, nothing different from the previous section. X to 2/3 plus 1 over 2/3 plus 1 minus x squared over 2 plus a constant c. I will plug in 1 everywhere and get -6. -6 when I plug in 1 and determine the constant. But I'll clean it up a little bit because 2/3 plus 1 is 5/3 and I have to flip 5/3 into 3/5. So let's do that. So f of x equals 3 over 5, x to 5 over 3 minus x squared over 2 plus a constant c. And the answer is -6 when I plug in 1 in x, of course. So 3/5 minus 1/2 plus a constant c. To determine the constant, I will subtract 3/5 and I will add 1/2. So then c will be -6 minus 3/5, but plus 1/2. So the least common denominator is 10. This one needs a 10. This one needs a 2. And this one needs a 5. So -60 minus 6, but plus 5. So this will be -61 over 10. So now I have the unique function, and that is f of x equals 3/5 x to 5/3 minus x squared over 2 minus 61 over 10. Again, this was just a warm-up. And now let's look at another type. And let's start with, let's say, 17. So this is called, so these are all simple, separable differential equations. What does this mean? We will separate the variables. Separate the variables. One variable on this side, let's say with dy, and the other variable on this side, let's say with dx. There is no x here, and there is no y here. This side has only y, and this side has only x. Do I have to have y and x? No. I can have volume and time. I can have weight and time. But what I'm saying here is this side has only one variable, and this side has the other variable. This is what we're trying to do here. And then, of course, we will integrate both sides. I'll explain the mechanism on as many examples as we need. Okay, so let's start with a simple one, as I said, like 17. So we have dv over dt equals -1.33v. We're asked, find the general solution and then check it. They're not given an initial condition, they just say, find the general solution. What does this mean? Of v, of course. How do I know? V is a function of t. So of course we are trying to find the general solution, V of t, whatever it is. How do I know again? From here. This notation specifically tells me V is a function of t. What does it mean to solve a differential equation? Find the function. Okay, here we had just examples with check. This was the function. This is the function that solves this. We're not going to solve these complicated differential equations in this class. We are only looking at two types. We don't know how to solve this. We're going to look at two types. A very simple one to find the function. And what is the second type? Separable, in which we can separate one variable on this side, which is basically the function, and the independent variable on this side. Okay, so I'm looking at this situation and I see, wait a minute. I see V here, yes, in the form of dV, but I see V here. I can have V on this side and on this side as well. What are the two variables, so to speak? V and t. T cannot be here. If V is on this side, this V has to be here on this side with the V, and dt has to be on this side, not with V by itself. So I have to try to separate the variables. First step, let's do it slowly. I will multiply both sides by dt. When I multiply both sides by dt, I get dv equals negative 1.33v, of course, times dt. Well, this is a step in the right direction. I have a number, that's fine. I have dt on this side, that's fine. But I'm having a difficulty, a problem here. I don't want this here. This cannot be here. This somehow has to be on this side. What should I do to both sides to have this on that side? Just remember, this is multiplied and this is multiplied.
Divide.
Yes, exactly. Divide both sides by v. So now I'm happy. So, did I accomplish this? Yes. I have one variable on this side with its corresponding dv, and I have the other variable on this other side with its corresponding dt. dt and dt are only here. I don't even have t, but I have dt are on this side, and v is on this side by itself. Whatever. And there must be a dv as well. One more time. Whatever dv equals whatever dt. And I have it. I separated the variables. Okay, so now at this point, I integrate both sides. Exactly like we did with finding dy over dt, we differentiated both sides, right? We differentiate this side and differentiate this side to find dy over dt. Now we are integrating both sides. Okay, so where are my props? So forget about this side for a moment. Imagine that this side does not even exist. I'm asked to find the integral from dv over v. What does this equal to? We've used it many times before. Many times. This is not new. It's okay if you're wrong. Just give it a shot.
Is it ln of v?
Very good. Awesome. Excellent. So the natural log of the absolute value of v is 1 over v. Great job. Now forget about this side and tell me what we get on this side. Forget about this. What is this? constant in front, which function prime is 1, because the constant is outside, and here I have 1. I have to have something and not 0. So I took the constant outside, so I have the integral from 1 dt, which function prime is 1.
Would it just be t?
Exactly. Awesome. Plus a constant c. You can say, wait a minute, you didn't put a constant here. It doesn't matter. I don't want to have two constants. Even if I put constant here, I will move it and get one constant. There is no need to write more than one constant. Awesome. Excellent. Now, keep in mind that this is only algebra now. Calculus was done, right? So I need to determine v. So I have some number here, some expression, it doesn't matter what it is. And I'm trying to solve. This is a number. Treat it as a number. I have natural log of something equals a number. How do I solve for this? What is the base here? I don't see a base. But we know what the base is for natural log.
It's e.
Exactly. It's e, indeed. So, let's say I have natural log of the absolute value of v is 5. How do I solve the equation? Assuming that it's 5. Let's do that on the side. I'm going to erase it. So let's say I have natural log of the absolute value of v is 5. It's not. I'm just giving an example. How do I solve this equation for v?
Wouldn't it be e to the 5?
Exactly.
Those absolute values.
Absolutely. Excellent. It's e to the 5th power. Same thing here. Who cares what I have? I don't care. It's e to all this. And I'm just going to copy it, exactly what I got with the 5. Of course, this is not what I'm interested in, but this was a side example, so we understand where this is coming from. E to whatever equals the absolute value of v. Okay, let's see what whatever it is. No problem. Negative 1.3t plus a constant c. Okay. Now, one other property that I need to discuss so we can continue. So if I have e to a plus b, this is the same thing with e to a times e to b. How do I know this? It's because the base to a power times the same base to another power. I copy the base and add the exponents. Copy the base and add the exponents. This is going back and forth. So if I have this, I can change it into this. But if I have this, I can change it into this. And you can say, why? Why would you care? Here's why in a moment. So the absolute value of v equals e to negative 1.33t times e to c. The reason why we do this is because we want to denote this by a constant c, or if you want to call it c1, call it c1, not to be confused with that. It doesn't matter. It's a constant. Call it c1 if that's what you want. The absolute value changes into v equals plus or minus this constant, c1, e to negative 1.33t. Now you can say, I want to call this constant c2. Fine. V equals whatever constant times e to negative 1.33t. And you can call this the way you like. You can call it c1, you can call it c2, you can call it c. What is involved in here? Plus or minus e to c. But we want to have clean function and the constant outside. So we determined v, which is actually v of t. This is the function whatever e to negative 1.33t that verifies the given differential equation. It's guaranteed dv over dt. When you differentiate the function with respect to t, you will get this. Any questions? Now they're asking us to check. That's a good idea. At least for one of them we should check. They're asking us now, check. Back where? Here. And our starting point, dv over dt, negative 1.33v. Okay, fine. Okay, so let's determine the left-hand side. dv over dt, we know what that is. It's bring down negative, right? We differentiate this, right? So it's negative 1.33 times the constant times e to negative 1.33t. This is the left-hand side. The left-hand side is negative 1.33. I'm differentiating this with respect to time, with respect to t. I shouldn't say time because I don't know what t is. With respect to t. So the constant stays in front. I differentiate e to a function times the function prime. And now let's see what we have on this side. This is negative 1.33 times v. Are these two the same? Is this the same thing with this?
Yes.
That's it. So then I checked. This is indeed correct. Yes. It is the solution, or a solution, of the differential equation that we started with. And this was a separable differential equation. Close to simple in a way. Let's look at the same type of example in which we are given an initial condition. So let's see how we work on that. And I forgot to number my pages. Okay. Any questions?